This video is going to serve as an introduction to nth roots. And as you look at this name, you're probably wondering, well, what the heck is that? What is an nth root? Well, n is just a placeholder for a number. It's kind of like one of your variables. And you deal with, hopefully, roots all the time. You generally see it in the form of that symbol, a square root symbol. So that we know, oh, the square root of 9 equals 3, because we know that 3 to the second power, or squared, is 9. So to undo the exponent, or the square, we have what's called a square root. Anytime you take the root of something, you're trying to figure out the base, the number that multiplies by itself to get that number. And square roots are pretty simple. They're just, what are you multiplying by itself twice to get there? So we've got 3 times 3 equals 9. If we had the square root of 25, that's 5, because 5 times 5, or 5 squared, is 25. But our root system does not stop there. The nth means it could be something different than a square root. And that's what this video is going to focus on. So let's dive right in. If you've been working with squares and square roots already, this should look pretty familiar to you. You know that 2 squared means 2 times 2, which is 4. You know 2 to the third root, or 2 to the third power is 2 times 2 times 2, which is 8. And then 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. So that hasn't changed at all. What is new in this video, though, is, alright, I have 4. I want to take it back to 2. Well, I use my square root. Square root of 4 gives me 2. Technically, it gives you plus or minus 2, but we're not going to focus on that right now. It's the square root of 4 is 2. Now, if I want to take 8, though, and get it back to 2, the square root of 8 isn't going to do that for me. So if I just tried the square root of 8, it is not going to equal 2. It's going to give us something that's pretty close to 3, 2.8, 2.9, something like that. So how can I get it back to 2? The answer to that is nth roots. So instead of taking a square root, like this, I have to add a little 3 on the outside. Now this is no longer a square root. This is a cubed root. I take the cubed root because I used 2 to the third power, or 2 cubed, to get to 8. And now the cubed root of 8 is 2. And it's the same idea if I want to get 16 to 2. I raised it to the fourth power, so I have to take a fourth root. And that just looks like the square root symbol, but instead of nothing on the outside, I have a little 4. So the fourth root of 16 is 2 as well. That is the basic premise of our nth root system. Instead of just being square roots now, we can have cubed roots, we can have fourth roots, they can be anything. Sometimes we have perfect roots, so the 16 is a fourth root, or a perfect fourth root, because it gets us to a whole number, but the higher it is, less likely it's going to be a whole number, it's going to be a decimal or something ugly. But thankfully, in this video and what you'll be working with, hopefully it'll stay simple. Now let's bring it up a notch. We've talked about something basic like the powers of 2. Now let's get some variables in there. Here we have the fourth root of 16w to the fourth v to the 8th. Looks kind of intimidating, but first thing we got to notice is the number on the outside of the radical, letting us know that this is a nth root. It is the fourth root, so everything here, we've got to make sure that we are not taking the square root of, but the fourth root of. So we've got our friend 16 again. And actually, as we're getting used to this, I'm going to recommend breaking this fourth root down into 3 pieces because we have 3 terms underneath. What do I have here? I have the fourth root of 16. I have the fourth root of w. And I have the fourth root of v to the 8th. And actually that should have been w to the 4th. Sorry about that. I've got these 3 pieces and I can break them down and work on them separately. So let's take a look at our whole number first. I've got 16. What we hopefully remember from a moment ago when I had it on the screen is that 16 is actually, I could actually rewrite it as 2 to the 4th. And since it's the fourth root of 2 to the 4th, our answer for that is just going to become 2. Now I've got here w to the 4th, and I'm taking the fourth root of that. Well, these 4's will cancel each other out. If you take the fourth root of something raised to the 4th power, you're undoing everything you're multiplying with. So that just becomes w. And then lastly, I have v to the 8th. And what I'm going to do here is I'm going to take that exponent and, like I did here, or sort of there, I want to try to rewrite v to the 8th so that it's got a 4 in the exponent somewhere. How can I do that? Well, I need to remember my exponent rules. If I want to get 8, I can have v squared to the 4th power. Because if you're raising a power to a power, you multiply them. So 2 times 4 gave me 8. And I want to have this 4 here so that it can be canceled out by this 4 there. So if I take the fourth root of this, these are going to cancel out, and I'm just left with v squared. So the fourth root of 16 times w to the 4th times v to the 8th is this, which is kind of nice. It is 2wv squared. That would be our final answer for this problem. But what if things aren't as nice as this problem? I specifically picked this one because everything went to a fourth root. Or worked out with the fourth root, I should say. What if it doesn't? Let's take a look. This time I am looking for the 5th root of 32 x to the 7th y to the 10th. I still recommend, just like before, breaking this down into as many pieces as we need. So I'm going to do 3 pieces again. That way I can see how it works with everything. I'll start off with my whole number, so I want the 5th root of 32. And hopefully you can figure out what times itself gets us to 32 if you multiply it 5 times. But if not, you can still do this on your calculator, at least for the integer part. Can't do it with the variables. The 5th root of 32, well, we can rewrite this as the 5th root of 2 to the 5th. Because if 2 to the 4th was 16 in our previous example, multiplying by another 2 gets us to 32. And if you're not all great with your powers of 2, that's all right. It'll come with time. So I've rewritten it as the 5th root of 2 to the 5th. So these will cancel each other out, and we start off our answer with just 2. Now I have x to the 7th. And this is where we start to have a little bit of an issue. Because if I want the 5th root of x to the 7th, I can't use my little trick here. There's no way I can write this as, well, x to the 5th in some way, shape, or form. Which isn't 100% true. I could break it apart, but it's really hard. So what we're going to do is we can leave it like this. Or what we can do, we have a couple options. Since I'm taking it by the 5th root, I can rewrite it as x to the 7 divided by 5. Or our last piece. X to the 7th is really x to the 5th times x squared. I can take the 5th root of this. It's just x. I can't take the 5th root of this. And because of that, I would have to do what I did here and make it times x to the 2/5, which just looks weird. So my suggestion, leave it like this unless your instructor gives you a specific way to handle it. So we'll just change this down here to be x to the 7/5. Whenever we're taking a root of something, if it doesn't go in evenly, we can put it on the bottom as a denominator for our exponents. And now we can do our last piece. I have here y to the 10th. So I want the 5th root of y to the 10th. Well, I can rewrite y to the 10th as the 5th root of y squared to the 5th power. Because just like in our last example, a power to a power means multiplication, and 5 times 2 gives us 10. So these will cancel themselves out, and we are left with y squared. Notice how nothing down here looks really crazy. We have this kind of ugly exponent right here, but it still works out. So the 5th root of 32x to the 7th times y to the 10th ends up being 2 times x to the 7/5 times y squared. And with that, we get to the end of our video. Hope you found it helpful, and good luck with your nth roots.